On the bench today we have a realistic model HTX 100. This radio was sent in from a viewer right here in North Carolina, over in Rayford, which is about 100 miles away. And the complaint that he was having is that he can't see the display that well. Well, as you can see right here, there is a bad spot in the display. And if we turn the radio on, you see part of the display is covered up, and there would be information here that you would normally see that you can no longer see. Now, this radio has been out of production for a while. They came out in 1988 and went well into 1990s for these radios. They're good little workhorse units. I personally have one of these myself, and I have worked all over the place with these. It's just hard to beat this little radio. Now, these radios are very similar to the HR2510. All but this has, is only CW and upper sideband, where the 2510 is full mode, AM, FM, upper lower sideband, CW. These are not. Well, as I said, they haven't made this radio in a while, so trying to find a display is hard to do. Well, I went on a forum and posted a want ad, and the guy told me that he knew somebody that had one, and the guy got up with me, and he happened to be another one of my viewers. So he sent in this radio, and what I can do is use the display out of this radio to fix the customer's radio. So it's not going to be about swapping the display in this radio. It's going to probably be about more, does this radio work? The guy said it does no longer come on. So what I want to do is get in this radio and see if it'll work, and if we can get it to work. Still going to use it as a donor to remove the display out and put in the other one. And if I can get this radio to work, I might go ahead and see, can I find another display and put in this, or maybe change the display to something different, but get it so that the radio will be workable again. And probably what I like to do, if I can get this radio back going, is just randomly give it away to one of the viewers that would like to have a good 10-meter radio. So we're going to look at doing that, and like I say, they are great little radios. So let's put some power to it and verify that it does not power up. Okay, I have the radio connected to the power source, and the switch is already on, and as you can see, there's nothing. So I'm going to go ahead and crack it open. We'll take a look at it. So if this would be a tube rig, I would not have put power to it and tried it. I would have went in and started looking first. But since this is just a solid state rig, it already doesn't work. It doesn't hurt to put the power to it and turn it on and see what you have. With a tube rig, you could have all kinds of problems going on. You'd be scamping trying to get things unplugged and get the smoke out of the way. But since it's solid state, it's pretty fine to go ahead and plug it up and turn it on. I've got the covers off of it, and what we're going to do is take the voltmeter and go in and trace the power rails and see what we have. Okay, so I've got the schematic pulled up here. As you can see, this is our negative rail coming in, and this is our positive rail coming in through the jack, and it has our protection diode across it. There's no fuse inside the radio. It's fused outside the radio. So if we look at it here and we come in, we go through this coil, which I cannot read what it is. The schematic is not the best. It's about the best one I could find for download. It looks like I need to go ahead and order a factory service manual on eBay if I can find one. But we see we come up through this coil, we go through the power switch, and then we turn off here and we go to another circuit, and then we come this way into a different circuit. The circuit that's coming off the end of the power rail goes to our final amplifier circuit. So what we're going to do is go in here and probe this circuit and see if we can find where we're losing our power at. Okay, so we had the radio turned over and we clicked directly to the negative side of the power supply rail. And we'll come here to the positive side and we'll test it right here at the plug. And we see we're at 13.8 volts. Now I have seen these plugs break inside and you're not getting connection through them. Or either the little barrel that the pin slides in gets wore out and over time opens up and it no longer makes connections. So I'm going to just go on down here and check on the board, because this wire could be opened up inside. And we have our 13.8 volts here. So this is the trace that we're coming through, and that'll come here, then it'll jump over to this trace, and we have 13.8 volts there. Now, could it be that the black wire is open inside? This is possible. So I'm going to just come here, I'm going to touch on ground, I'm going to come here and touch on the other side of the diode, and we have 13.8 volts. Well, since we're showing 13.8 volts on the rear of the radio, we're going to move up to the switch, and we're going to check both legs. This off on switch is mounted right on the back of the volume control. So we're going to check the red wire from the rear, and we have nothing. And we'll check the brown wire anyway, and we still don't have nothing. So we have no power even getting to the switch at all. Now, the only thing between the coil and the switch is circuit traces. And to get to these circuit traces, we'll have to remove this unit and fold it over to see what's behind it. So this set of wires here is the orange and brown wire that comes from the switch. It routes right on over, comes right down and goes to this white connector that is soldered to the board. So we need to go in here and find out just what's going on the other side of this. So I went ahead and removed the whole board. You just have to unplug 2 jacks and 1 coaxial cable. Now we have full access to the bottom of the board. This is the mounting screw, and right next to it is that connector. And just taking the board off, I'm already seeing some of the, the problem. Now, what caused the problem, we're not sure yet. I'll come on and focus now. As you can see here, coming off of both pins, you can see that solder trace is blown in two, and the other solder trace is blown in two. Now, the only thing there's several things that could cause that. Something happened where the power lead got reversed in the back. It did not blow the protection diode. Could be a wire shorted in the back while it was plugged up. Or here there's an 8-volt regulator. Now there's chances that this 8-volt regulator has shorted and this blowed the trace. So before we go and fix these traces and turn the radio on, I think we need to look at this regulator. Well, I got my multimeter in diode mode. We're just going to go down here and we're going to check the pins on the bottom of this regulator. And that's showing a complete short. And And be on the safe side, we'll turn the leads around. So just by looking at this, it looks like our 8-volt regulator has shorted the ground. So what I'm going to do is remove that regulator and test it again just to make sure there's not something else across it that has shorted. I have the regulator desoldered from the board, and we're just going to go back and check it again. Open circuit, we should show a drop. Open circuit and a drop. Well, it looks like our regulator tests good, but we noticed when we were soldered to the board we had a direct short. What we're going to do is put the red lead on the ground, and we're going to check across all 3 pads. Direct short, direct short, direct short. So that tells me we definitely got something on the pads from the voltage regulator that is shorted the ground. So we're going to have to get in there on the schematic and look around and see if we can find out what's going on. So looking at our schematic again, we see we leave the switch and we come up here and we divide off, and this side goes to our IC501, which is our 8-volt regulator. As you see, the input comes in on pin 1, pin 2 is grounded, pin 3 is your 8 volts out. And the first thing that you can see, if I zoom in on that just a little more, I'm sorry about this terrible schematic, but the first thing you see on the input and the output of the voltage regulator, we have 2 electrolytic capacitors. So we already know that the radio was not hooked up backwards, or nothing got shorted in it, that something is shorting the 8 volts rail out and blew the traces going to the 8-volt regulator. So let's look at this. I want to say it might be C96 and 97, but we'll look down there in the radio and see if we see that. So again, here's our 2 wires coming from the switch. Here's our 8-volt regulator on the rail, and I see 2 caps here back to back, and there is no capacitor designator on the board. So I'm going to have to look at the input and the output and see if these are connected through those 2 capacitors, and we'll need to pull those capacitors and check those. Here, looking at the bottom of the board, we can see these 4 capacitors here in a row, and if you look, you'll see one outside pin is tied directly to one of the capacitors, and there's another pin tied directly to the other capacitors. So we're going to pull these capacitors out and have a look at those. Okay, I pulled the 2 caps out and I checked them, and the capacitors, they're 10 microfarads at 35 volts. They both check good. So we still have a short to ground. I decided to go ahead and look on the input, and we can see the input of the jumper wire, and it comes on across, and as it's coming around, I noticed right here you can see there's another burn spot on the board. But if we follow this right on the round, you can see it comes to this lug here and stop, and there's another lug. So that's a big capacitor across here. So we need to have a look at this big capacitor and see what's going on. Alright, I got our capacitor hooked up to our little cheap Chinese component tester. One day I'm going to get me a proper tester and this capacitor seems to be checking as a resistor and a choke at 0.04 ohms. So that's definitely, the capacitor has went kaput. Yeah, I've been looking at maybe getting an Atlas component tester, and then maybe something like a Bob Parker ESC tester. Now I have several transistor testers here. I've got pretty decent one, analog meter testers that checks components good. But being old school, it's always been good. But I would like to go ahead and get one of the, at least two of the other items I mentioned. But anyway, it looks like our capacitor here is bad, and you can see it's got a bunch of Sony bond all over it. It looks like 1,000 puff at 25 volts. Shut the meter down. We'll hook it up the other way just to make sure. Yeah, hooking up backwards, it shows 31 picofarad. It's definitely bad. So looking at the one trace here, it was just had heated and it took the conformal coating off, so I went ahead and scraped it back and run some sort across it just to build the track back up. And here on the front I went ahead and scraped the coating off the traces, and I'm going to just put some bond wires across it, and then I'm going to cover all these with conformal coating so they'll look like it's supposed to be. Sometimes, I would go in there and get my repair kit, and I would cut out new copper traces and glue on the board. But for this, I don't think we really need to go to that extreme. We'll just go ahead and put some bond wires across it and put some conformal on it, and she'll be good to go. Alright, so we got our regulator sorted in. We got these two traces fixed, and all I used was just some piece of wire, multi-strand wire. Just cut it out, pull out a couple of strands, solder across them, and we'll get this cleaned up and put some formal coating on it. But I'm gonna wait to do that because I think I'm gonna go ahead and replace all the capacitors in this board. In fact, I'm gonna go ahead and order 3 more sets, and I'm gonna do both of these radios. And plus mine are about 10 years old, so probably wouldn't hurt to go ahead and replace them also. But we'll check and make sure we don't have no shorts. Now, set the board back in. I want to remind you, if you're working on one of these and you take this board loose, make sure you set it aside. Do not lay this board back in the radio to do any testing. If you notice on the back of the board, there's 2 tabs on each side. That's to hold the board up. If you leave the front 2 screws in, this holds the front of the board up. So now this will pivot so you can test components on the bottom side of the main board. If you don't put these 2 screws in, this here will drop and actually short out on the other board, and there's a processor right underneath of this. So you don't want to short that out. Okay, the radio's all back together, and we'll go ahead and turn it on and see if we get anything. And we have a frequency readout. Then I'm on single side band, because that's the only mode it goes other than CW. And I'm going to switch the OF generator on. And we do have fairly decent receive. Let's change it over to the antenna, or to the watt meter. And we'll key it up and see if we have anything. Test 1 2, test 1 2. Okay. Look at a big giant watt meter. Test 1 2. Test 1 2. Radio check 1 2. And it's looking real good on the meter. Check 1 2. Check 1 2. Test. Radio test 1 2. Looks good on that, and looks good on the spectrum analyzer also. Test 1 2. So it looks like we got a decent radio to work with. Like I said, these radios have, came out in the 80s, late 88. So they got a lot of age on them, and those electrolytic capacitors are not going to last you a long time. They're going to go, and you can see this one here has Sony bond all over it, and it's YEC capacitor brand, 1000 puff at 25 volts, rated for 85C. So yeah, I'm gonna go ahead and order 3 sets of these capacitors, and go ahead and change this one out, and I'm gonna pull the display out, and I'm gonna start looking for another display or a way to come back and fix this, because this radio was sent in to use for parts. So we're going to use the parts out of it, and then we're going to rebuild it and get it back going. And I don't think the guy that sent it to me will mind me passing it off to someone else, maybe someone out there that does not have a radio. We'll look and see how we can work that out and come up with a way to get it in good hands. Anyway, just a short little troubleshooting diagnostic. This doesn't fix the other radio for the customer, but kind of shows us how we go about looking at these problems and different radios, getting some age on it. With tube rigs, wax capacitors and paper capacitors always have a problem. As you can see, even in solid state stuff, these capacitors can really be a pain. Anyway, thanks for watching. Leave your comments down below. I'll leave a link to my website if you want to discuss anything on this, and we'll see you in the next video. And also I want to mention that you got a radio, the S meter doesn't want to work right, or receive sensitivity's down, or you get some funky things when you hit the buttons and stuff. Electrolytic capacitors can cause all that. So by taking a radio like this and go ahead and change out all those electrolytics, sometimes can eliminate 99% of your problems, and you only have a few problems left to sort through. But changing those out is always a great idea to get done, because capacitors, cheap brand capacitors don't last but just so long, and with the age that gets on them, it'll really wreak havoc on you later on. So it's always a good idea to change out those caps. And one last thing, this video will be edited on a brand new machine that was sent in from a viewer, and as you can see, I have 3 monitors on this machine. I also have a way to switch over, and there's a laptop sitting in the corner. There's a keyboard and mouse board over there, but I can also display the schematic up on that screen. But sitting back behind the monitors is a Dell Optiplex. This is a 7020 Core i5. It's a 3.3 gigahertz processor with 4 gigabytes of RAM. I will be upgrading that up to max, which is 16. And I can tell you this computer is pretty fast. It's getting the job done, and I will be adding this to a mailbag in the future. I usually go ahead and shoot the footage for the mailbags and just hold on to them until I get enough stuff together. So anyway, a big thanks to John out there that really helped with building this computer up and sending it in. And as always, I hope you found this video useful. If you did, leave your comments down below. and I'll leave a link down to the website if you want to go over there and discuss this. And we'll see you in the next video.